Hey everybody, and it's another PCB bench repair session. Today we're going to be looking at Championship Sprint. And I'd just like to say at the start of this video, thank you very much to Colin D from UK VAC, who has helped out immensely on this and helping me understand what's actually going on the board. So this is a Championship Sprint. It's an Atari System 2 board. This is the video board down here, with basically the guts on it, and here is the CPU board with the glory on it, I suppose, if you want to put it that way. It's an unbelievably complicated wiring harness to be able to do it. It requires multiple 5 volts and a 15 volt rail. It's a medium res game. We've got it linked, we're getting some 5 volts off the, in fact we're getting all 5 volts off the jammer switcher, which is in the super gun. And we're getting the plus and minus 15 from the Atari Ghetto Blaster looking test rig that we've got over there with an AR3 on it. So that's the test bench, and so we've got the plus 5 and grounds there, and we've got the test rig, test button, sound output, and plus minus 15 volts there. Okay, so let's show you what the problem is. I've had to bring the Paperboy cabinet into the workshop to show you this. So here's Championship Sprint running on this medium res monitor, and straight away you'll see that the cars, as they're drawn, are kind of doubled up. Let's see if I can zoom on one of them and follow it round. So as you see it, it's kind of like showing the top half of the car, and it's redrawing the same bit in the bottom half, and they should actually be 16 lines high, 16 pixels high. So I've had a look in the MAME driver for those to see what it's supposed to do, and had a look at what the screen's supposed to look like, which is incredibly helpful. Colin was generous enough to have a look at schematics for me and give me some hints, and unlike the Donkey Kong repair which I did a few days ago, this one is slightly different. It still has your V signals here, so you still have your 2, 4, 8 and 16V, and your MOV 1, 2, 3, 4, etc, etc, etc. Now, Colin's suspicion was that one of these 283s, this one here at 5M, was bad. And because what it was saying was basically that's an adder, and it's generating effectively a start address in ROM. So over here at the end of the chain you've got 15 lines worth of addressing which go to the ROM chips which have got the graphics in. I can't exactly remember, but here's the ROM block for the graphics, and they set up the address to pull from, and it's a 16-bit bus, so it puts 16 bits on the data bus, so you get your entire sprite width in one go. Now I was starting to look around the motion object line buffer, which is more the horizontal side of it, and how it shifts it along a line to put it into an exact pixel position across the line. What we need to do is get the data from the ROMs into that RAM to start with, and if you're not drawing all the data in one go, then it's no good. So what Colin said to me was, he said, hey, start around here and have a look at the signals coming off these chips over here. So we had a look at MOV 1 to 8 and all these ones over here. Now I did actually put a post over on UK VAC asking for some help on decoding the signals, because understanding what the signals mean is kind of half the battle to figuring out what's actually supposed to be going on. Colin says you can do it sort of almost blind for that, just have to understand what a few basics are. So the one he immediately told me to have a look at was this one here, this 5M chip, which is an LS283 adder. So effectively what it's doing is it's adding one of the 2V, 4V, 6V, 8V or 16V signals to the position of MOV 1, 2, 3, 4, which is a partial offset. Now if up there's a complementing one as well that works with 32, 64, 128, 256, which gets a line position down the screen. If you add all those up, you get vertical positions, and you've got MOV 5, 6, 7, 8 as well, which goes with it. So I had a look on the scope, and I couldn't actually see much wrong with it. All the input lines were all correct, and the output lines looked correct. It's very, very difficult to tell. So what we did next was we got the old logic comparator. So there's the logic comparator. And we're going to do there's a logic comparator, and I'm going to pop on this onto 5M. Let's have a look. KLM. If I can do it in one hit whilst holding the camera, I will do. Right, logic comparator's now sat on top of that chip, and it's arguing. Now, The screen hasn't changed, but that's because the logic comparator doesn't allow the data to flow back down the legs of the pins. It's not like directly piggybacking a chip. But this is a, what is it? It's a 16-pin device, I think. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 16-pin. So this is complaining. Sorry, it's an 18. Is it a 16 or an 18? Anyway, it's complaining about legs, specifically about legs, 9, 10 and 13. Well, 9, 10 and 13 over here, well 10 and 13 are 2 output pins anyway, so that's definitely something that we'd be concerned over. And 9 is an input pin, so there's a good chance that something around that area inside the chip is physically blown. So take that off, and yeah, it's definitely a 16 pin. So what we do next is we try to piggyback a chip onto it. So the logic comparator is saying it doesn't agree, so I'm going to piggyback this chip over the top of it, so if I can do it one-handed, and the camera, make sure I've got it the right way around, otherwise it's going to explode, and that'd be very funny to do on camera. Not so much for the chip itself. Yeah, that's the right way around, it's on the right chip. LM. So what we'll do now is we'll go over here. We've still got, I must not have seated it correctly. Just give me a second whilst I do that. Right, I've now piggybacked the 5M chip with another known good working LS283, and if we look over here, we get an immediate change on the cars. So it's not perfect, but it's proving that data is definitely being more organised as to what we're expecting. I would imagine that the reason why we're getting extra data vertically is because of that pin 9, which was MOV3 or 4, whatever it was. So the next step is going to be to whip out that 283 off the board and change it over. So let's see if we can do that quickly. And there we go, I've pulled 5M, the 283 out the board, and put it in the logic tester. Oh look, not found. Let's go there, let's go LS, like so, go across there and put in 283, 1, 2, 9, 8, 1, 2, 3, see what it says. Oh, 282, 283, there we go. Fault. Ta-da! So it was right, and Hunch was right as well. So let's throw that away, and let's stick a socket in and stick a new chip in there. There we go, one LS283 placed back in the board, a brand new one working, tested, verified. Let's power the board up and see what happens. So point you at the cab and switch on. And there's the Champ Sprint. So this will either be fixed or nearer to fixed. When we go around here, there's the high score table. And there we go. And we're fixed. Ta-da! Well, that's about as much as I can do for this particular one. That solved the problem that's reported to me before I hand it back to Andy and put it back in the machine, and then everybody can play on it up at the arcade. We will just hook up the sound into the sound into a speaker. Sorry, I'm completely mincing my words. What time actually is it at the moment? It is 23:42 at the moment. So yeah, probably leave that just to run, but I doubt any more problems are going to develop with it. I'll stick the sound onto it and just make sure that that side of it works. Unfortunately, I can do nothing with it apart from run through its test mode. So what we'll do is we'll hook up the speaker and we'll hook up the start 1 and 2 controls onto this loom, which I need to do anyway. And at that point we'll run through the test mode selection on it and see what happens there. But everything should be absolutely fine now, as far as I can tell. And whilst I've got the bench set up for doing these System 2 boards, I do actually have another Paperboy with a fault to fix. So we'll probably pull that out and have a look at that one and see if we can't fix that as well. It's an interesting fault, and you'll love it when we put that on the bench, but that'll be probably the next video or the video after. Anyway, thank you very much again to Colin for giving his time over to help out with this one by giving me a bit of a pointer in the right direction. And also, don't forget to hit the old subscribe button up in the corner if you want to see more videos like this, and tours of the arcade, and tours of the events that we do, and all that sort of thing. And don't forget, if you're up in the northwest, please do go and visit Arcade Club over at our place in Haslingden. Full details are in a link in the description below. So until then, see you on the next video. Adios for now. Good night.